All right, so since nobody knows how to do this fluency, which I really just think is because people are lazy, let me go ahead and do the first one for you. We have a trapezoid here, and the only way that we can find the area of a trapezoid is if we decompose the shape. So I'm going to go ahead and draw a line right here that makes a rectangle and a triangle. For the rectangle, we have a length of 3 and a width of 6. 3 times 6 means that the rectangle is 18. And then for the triangle, the height is going to be 3, but we got to figure out how long this is right here. If this entire line right here is 9 and this piece is 6, if we do 9 minus 6, that means that this is going to be 3. So for the triangle, it's going to be 3 times 3, which is 9, base time height, and then divided by 2. That's going to give you an area of 4.5. So then you take 18, the rectangle, and 4.5, add the 2 together, and you get 22.5. So Jalea said the answer for the second one is 14. We've got a triangle on the left-hand side, triangle on the right-hand side. They're both the same thing. So base time height is 3 times 2, which is 6. And then you got to divide it by 2 because it's a triangle. So the area of this triangle is 3. The area of this triangle is 3. The area of the rectangle in the middle is 8 because it's 4 times 2. And then you go ahead and add the numbers up. 8 plus 3 plus 3 is going to be 8 plus 6, which is 14. And then the last one, we got a really long triangle on the left-hand side. Base time height is 4 times 1, which is 4. Divide that by 2. The area of this triangle is 2. In the middle, the rectangle is 3 by 1. So that's going to be 3 times 1 is 3. And then right here, we got 1 times 1 on this right small triangle. So this height is 1. The base is 1. That gives me 1. But when you divide 1 by 2, you get 0.5. So 2 plus 3 is 5. Plus 0.5 is going to give us 5.5. All right, so moving on from the fluency. Good job, Michelle. Nobody cares. Here we go. Next thing, as you can see, the title of this lesson is Volume of Prisms. So we have a prism that you can see here, where we have a 3, a 3, a 4, a 4, and then a 6. Can you please find the volume of this prism? Yep. Find the volume.
Well, which one?
I can't even see from right here.
I just told you it's 4, 4, 3, 3, and 6. I'm only giving you like a minute. So find the volume. You should remember the volume formula from like 4th grade.
Length time, height.
That's it. Length time, width time, height. That's the primary school one.
I don't remember.
No.
I don't remember those.
Sir.
She just told you. Stop talking and do it. Bless you.
Leave me alone, sir. And I got the answer.
You got an answer. What answer might you have, ma'am?
72.
She said 72. Anybody agree with the mind that the volume is 72? Julia got her hand up. Kenzie got her hand up.
Right, you can write nothing.
So the volume is equal to length times width times height. If we look on the length, we've got a length right here of 4. We've got a width right here of 3. And then how tall this thing is our height, and that is 6. So 4 times 3 is 12, and 12 times 6 is 72. 72. Now that's the primary school way to find it. There is another formula that you learned in 6th grade, and I'm pretty sure nobody remembers.
Nope.
So let me go ahead and show it to
I
you.
never put this one.
Oh, V equals base times height.
This is the one that we're going to be using, Kendall, today.
It's so quiet without y'all, bro. So that's all you want to just BH?
Well, we're trying to figure. I want you people to shut up long enough for me to explain to you what we got going on here.
But can I sit right down from
No.
the side?
We got volume is equal to a capital B times a lowercase h. What do you think this means? What do you think the V stands for? Volume. What do you think the H stands for? Height. What do you think the capital B stands for? Not just base, but the area of the base. Okay? So when we use it this way, the area of the base, we're going to have to look and see what the base is. Our base is right down here. What shape is that? A rectangle. How do you find the area of a rectangle? Length times width, right? So we would do length times width and then multiply times the height. So notice how it's the same thing because it's a rectangular prism?
Yeah.
Because this formula right here only works for rectangular prisms. Period. That's it. Alright? If this was a triangular prism, would it be length times width to find the area of the base? No, we would have to use base times height divided by 2. Okay? So that's why the first one, the primary school, when I say it's primary school, because it's only for rectangular prisms. Okay? Nothing else. But in this case, we would end up putting the same exact numbers, 4 times 3 times 6, and get 72. We'll still get the same answer if we find the area of the base. Okay? Now, when we were talking about surface area,
Oh, your filter is not working.
Stop putting your nigga along. What?
when we were talking about surface area, we found the surface area of a rectangular prism, and then we cut it down the middle and made 2 triangular prisms. And y'all told me that y'all thought that the surface area was going to be half, right? Because we had cut it in half. But was it half?
No.
No, it wasn't. It wasn't half because we had that extra side that was created, right? And you could touch that side. If I take this, which we know that the volume, and volume means surface area meant all the sides on the outside that I could touch, right? Wherever I would put wrapping paper at. Volume means if I was to fill this thing up with water, how much water would I be able to fit into it? So in this particular case, I could fit 72 cubic units of water in here. Okay? If I was to cut this thing down the middle, all right? So using a plane, I made me a cross section here and cut it, and then I slid them apart. Which shape do we still have? Two triangular prisms, right? Do you think the volume of a triangular prism, do you think it's going to be half of 72?
Yes. No. Because they still got the other side we could touch.
But are we worried about size that we're touching here? Are we talking about surface area?
Oh, yeah.
The surface area is size that you can touch, right?
Yeah.
Volume is
The inside.
how much water you can fill in there, right? And then if I take it and slide it apart, did the amount of the insides change? We're going to figure that out today. We're going to decide whether it would be half or not. So today we will determine how to find the volumes of other types of right prisms, such as triangular prisms. As we do, consider how we can use what we already know about finding the volume of a right rectangular prism to help us find the volume of prisms with different shaped bases. Alright, let's go ahead and move to the next slide. Alright, so with rectangular prisms, any pair of opposite sides can be considered as bases, right? Rectangular prism, we can lay it like this, we can lay it, stand it up like this, and however we change it could end up being the basis. On triangular prisms, it's not the same because the triangle has to be the basis no matter how it lays down. So, which rectangular prism, any pair of the opposite, with rectangular prisms, any pair of the opposite sides can be considered the basis. Let's choose the top and bottom faces to be the bases in both images. So for both of these, the top right here and the bottom right here is our basis, the top right here, the bottom right here is our basis. All the same sizes, right?
Yeah.
We got a 4 going across right here, except they cut it so that this is 2 and 2. We got a 3 and we got a 4 and a 3. So what do you notice about the cross sections that are formed in these images? What do you notice about the cross sections in these two pictures? So,
One is color.
one's parallel to what?
Perpendicular.
One's parallel to the perpendicular? You're on the right track. Tell me. What does it mean?
The first one is parallel and the second one is perpendicular. The second one is parallel and the first one is perpendicular.
So one is parallel to the bases and one is perpendicular to the bases, right? Which one never touches the bases, meaning it's parallel? The first one or the second one?
First one.
The second one.
Raise your hand, you say the first one is parallel.
No, raise that hand. Raise that hand.
So the second one is parallel to the bases. It never ever touches or ever passes through the bases. So this one is parallel and this one is perpendicular. It cuts straight through the bases. Can you please use the middle school volume formula? Volume is equal to the area of the base times the height to find the volume of each half.
Yeah.
Go ahead and do that for me. Find the volume of each half.
For the first one?
For both of them. Do it for this half, do it for this half, and do it for this half. So we're trying to find the volume of one half of this prism, which is a triangular prism. And then we're trying to find one half of this prism, which is still a rectangular prism. So go ahead and find those two volumes using volume is equal to capital B times H. The volume is equal to the area of the base times the height. Alright, so y'all told me that y'all figured out that half of this prism was equal to 36, right? And so unlike the surface area, when the surface area wasn't half, volume actually is half if we cut it in half. So just for Jabron, since he didn't know how to figure out nothing, I'm going to go ahead and work these two problems out for Jabron. Kind of slow. So if we take a look at this first prism that we have right here, our base down at the bottom you can see is a rectangle. So if I want to find the area of that base, it's going to be 2 times 3, which is 6. And then we multiply that times our height, which is also 6. You can get it from over here. So then 6 times 6 is 36. Well, that was really complicated, Jabron. Do you understand how to do that now? You got it, Jabron? Okay. So then we move on to the other side. We have our base down here, which is a slightly larger rectangle. We've got an area of, we got a length and a width of 4 times 3, which is going to be 12, times the height, which is right here, and that's a 3. And 12 times 3 is 36. So again, it is halves. Half of the rectangle. The whole rectangular prism. Do you think we can find the volume of the right triangular prism using volume is equal to the area of the base times the height?
Wait, so I thought you said this is a do you even need our book?
We eventually we're gonna get to it, but this is like the last thing that we gotta worry about. What does it want to do with this?
Put your brush back in the tray.
We're gonna skip that.
Why did he show up?
Let's get the secret plans over there.
She is. She got it. You know he told me Kiara Friday? She got a phone message? Yeah.
Alright, so looking at this shape that we have right here, we have a triangular prism, which we know it would be half of a right rectangular prism, right?
Yeah.
Do you think we can use the formula length time width time height for this particular problem? Can we use length time width time height?
No.
Kendall shaking his head, yeah. How you think we can use that, Kendall?
You can't use that because it's a triangle.
Good for you.
And why we can't use it for a triangle?
Because a triangle is base times height divided by 2.
Good job, guys.
So it's gonna be, yeah, to find the area we gotta do base time height divided by 2, right? So this particular problem, we don't have no length or width, right? We can't use that. So what formula do we have to use?
Base times height divided by 2.
Not just base time height, no.
Surface area.
What formula for volume are we using?
Capital BH.
Who?
Capital BH.
So volume is equal to BH, area of the base times the height, right? Alright, so let's go ahead and use that formula to find the area of this triangular prism. And go. Again, this is half of the prisms that we've been dealing with all class period. So here we go, trying to find the area of this right triangular prism, which was half of a right rectangular prism. And we're using the formula volume is equal to the area of the base times the height. Now it seemed like the problem was people couldn't figure out what numbers to use on this base right down here. So let's go ahead and draw it on the side. It has a right angle, so it has to be a right triangle, so it's going to look like this. We've got a 3 right here, a 4 right here, and a 5 right here. Now because this is a triangle, instead of the area of the base for capital B, let's write down the formula how to find the area of the base. It's a triangle, so it's going to be base times height divided by 2. That's how to find the area of a triangle, right? And then we have to multiply that times the height. So let's plug in some numbers. Looking at the rectangle that I drew over here, what's the base? 3. Times the height, which is? 4. Do you use that 5 for anything?
No.
No, that's just another extra number to slip you up. And now looking at the rectangular prism, the triangular prism I should say, what's the height? 6. Alright, so let's go ahead and work this out. What's 3 times 4? 12. Divided by 2?
6.
It's 6. 6 times 6?
180.
36. So it doesn't matter, when we took that rectangular prism, it doesn't matter if we cut it perpendicular. It doesn't matter if we cut it parallel. It don't even matter if we cut it perpendicular and did it diagonal. Half of it is still half of the volume, right? So the volume is half of the volume regardless.
Just all it says.
Volume, pretty much, and cross sections. So I wonder if that works for every triangle. Does area of the base times the height work for all triangles? Let's take a look at number 2, and you can go ahead and knock number 2 out. Do it the same way we just did this one. If you get confused on the base, draw it on the side somewhere. You too, winner. In Malaysia. Since Malaysia ain't in class. ISF. Alright, so you go ahead and find your partners to work on problems 4 through 6. Apparently my camera wasn't recording for number 3, so I'm going to have to explain again how we did this one. So Jonah found the area of this rectangular prism first by doing this work. Then he found the area of this triangular prism by doing this work. He got the 2 answers for the volume of both those prisms, added them together and got 312. But then Nora said, why don't you just use the formula, area of the base times the height? So that's what we did. So we went ahead and looked at the base, which is this trapezoid. So to find the area of this base, you got to decompose it. Here's a rectangle, so length times width. Here's a triangle, so base times height divided by 2. Then you plug in your numbers. The length and width of the rectangle is 5 and 4. The base of the triangle is 3 because we had a 5 right here, so this piece is 5. And if this whole thing is 8, that only leaves us with 3 for the base of the triangle. And the height is the 4. So then we went ahead and did the work. 5 times 4 is 20. 3 times 4 is 12. Divided by 2 is 6. Add those two together, gives you 26 times 12, which is 312, which is the same answer. So a little bit, slightly less work. They said this is more work, but it really is only just multiplying times 12 one extra time. So you can go ahead and do 4, 5, and 6.
Okay.
All right, so we looked at 4, 5, and 6. So let's go ahead and take a look at them, see how they should have been worked out in case you're having problems with it. All right, so we're going to take this one piece at, oh my God, stupid website, bro.
Sir, I think you got the wrong answer.
You think I have the wrong answer? I'm sure that's what it is, though, Demaya. You're smarter than me, and I've got it wrong, and you've got it right. Anybody else agree with Demaya? No? Okay. Demaya said I'm wrong, and she's right.
I think he got the wrong.
So I'm not saying, I'm just saying, I think he got the wrong answer.
All right, so what formula do we use to find the volume of any prism?
V equals capital V lowercase h.
And what that stands for, I'd rather you say it the way it's supposed to be.
Base times height.
Volume is equal to, not base times
The
height.
times with the area of the
Area
base
of the base times the height. While y'all talking, y'all need to split up. Volume is equal to the area of the base times the height. So we got to find the area of the base first. That's our main goal. So I'm taking a look at this trapezoid. It has a rectangle right here. And then it has a triangle right here. So we got to figure out what this stuff is. So I know to find the area of the rectangle is going to be length times width. And I need to add that to the triangle, which is base times height divided by 2. That's how I'm going to find the area of the trapezoid. All right, let's get my numbers real quick. So I got a length right here that's 2.3, and then the width is not 2.9 because this whole thing right here is 2.9.
With this.
I just need this piece, which is 2.
How did you get 2?
That's what I had.
Because you go across right here, rectangles, opposites of rectangles are even, right? So that gives me a 2. So it's 2.3 times 2.
That's what we had, sir. You told us you raised it.
And then take a look at this triangle. If that part is 2 and the whole thing's 2.9, that means the base of this triangle is 0.9. So the base of the triangle is 0.9 times the height. So the height is on the opposite side right here. That's 2.3. And we gotta divide that by 2. And then the height of the entire prism. If that trapezoid that's looking at us is the base, we got to think about putting that down on the ground because the bases go on the ground. And then if we take that and just rotate it so that the front is down on the bottom, that means the height of the whole prism is right here, and it's that 1. Now we just go ahead and do the math. 2.3 times 2 is 4.6. And then 0.9 times 2.3 divided by 2 is 1.035.
And you give 5.635.
When we add those together, we get 5.635 times 1 is obviously 5.635 meters cubed. Is that the same thing I had on the
Yeah.
Alright. I was just checking.
I didn't say your answer was wrong, sir. What? I keep forgetting that. I hope my
Okay.
picture.
Again, it's going to be... Alright, let's get back in our regular spots. I can't deal with the little whispering, talking, and not paying attention to what we got going on over here. And you ask me 27 questions on Thursday when it's time for the test. Does anybody have any questions on this problem? Because it's easy when I do it, but I need you to be able to do it on your own.
Boy, if you don't sit down and tell me, you're not gonna be. Stop. Stop fooling me. You got it.
So upstairs. All right, now we have a right regular pentagonal prism. So you ready? Okay. So right regular pentagonal prism means that we gotta decompose that prism. Let me go ahead and write my formula first. Volume is equal to the area of the base times the height. So let me see about this base. If the only way that we can do these pentagons is to make them into triangles. So we're gonna have 5 different identical triangles. So to find the area of this base, I've got 5 different triangles that I'm going to be doing base times height divided by 2 with, and then I'm going to multiply it times the height. So let's see here, we got 5 triangles that have a base of 13.1 times the height of the triangle, which is 9. Don't forget to divide that by 2. And then once we come up with that, we're going to multiply it times the height of the prism, which you see right here is 18, because the pentagon is on the ground for this one. Why put what? 2 parentheses, because I got 1 open parentheses right here and 1 open parentheses right here. So I got to have 2 of them right there.
She asked you, like, why we have to put that?
It's to keep it organized, it's to show you that what's inside the smaller parentheses is how to find the area of one triangle. On the outside of that parentheses is that I'm multiplying it times 5, because I've got 1, 2, 3, 4, 5 triangles. So I'm gonna find the area of this triangle right here first, and then multiply it times 5 to do the whole pentagon. That makes sense? Okay. So going ahead and working this problem out, we got the 5. One of those triangles, 13.1 times 9, divided by 2. The one triangle has an area of 58.95. All 5 of them, which is going to be the base of my triangle, is 294.75. So that's the area of my base. And then I multiply that times 18 to give me the volume of my whole solid. It's going to be 530.55. And this is no units. Doesn't give me inches or meters or anything like that. So it's just going to be units cubed. So finding the area of the base first. You multiply it times the height. Any other questions on this one? If you got them, please ask them, because your question might be something that somebody else is too scared to ask. If they're paying attention. So not Jabron. Sean even got his book open today. It's on lesson 3, but his book's open. Alright, here we go. Moving on to the last one. Not the last one for us, but the last one for right now.
You still didn't show us in the point show.
We're going to do it after this. I thought about that while y'all were working. Alright, so it says find a volume of water that Eve's right rectangular hexagonal prism fish tank can hold. The line segment that has a length of 9.1 begins at the center of the hexagon and ends at one side of the hexagon. So that's going to be the height of our triangle. This one's done the same exact way as the pentagon, except it has 6 triangles rather than just 5. So we've got one triangle here. Here's a second, a third, a fourth, a fifth, and the sixth. So we're going to find the area of this one and then multiply it times 6 to get the area of that whole base. So volume is equal to the area of the base times the height. The base is broken down into 6 triangles. So base times height divided by 2 times the height of the whole prism. So 6 times, let's do the area of that one green triangle. Base is 10.5 times the height of that little triangle is 9.1, and divide that by 2. And then once we multiply that times 6, we're going to multiply it times the height, which that aquarium is 24 inches tall. Alright, math time. Got one green triangle, 10.5 times 9.1. Oops, I did something wrong. 10.5 times 9.1 divided by 2.
That's so big. Look at it. It's like this.
That one triangle has an area of 47.775. So then to find the area of the base, we're going to take that area of that one triangle, multiply it times the 6 triangles that make up the base, and that is going to be 286.65. So there is the area of our base. Then for the formula, all we do is take the area of the base and multiply it times the height of the prism. And we get 687.
9.6.
So 6,879.6. And that's in inches, not squared. This is volume. Cubed. Questions? All right. Possibly, if this ain't recording the whole thing, bro, I'm gonna throw that camera in the garbage. All right, so right here, this question, number 7 and number 8 are gonna be slightly different than all the rest of them that we've done, 1 through 6. So take a look and see what is different about this one. It tells us in the directions the volume of this right rectangular prism is 48 cubic feet. Did all the rest of them give you the volume right off the bat?
No.
No. They told you to find the volume, right? So it says that they want us to determine the height. So in this problem, we're not finding the volume, we got to find the height. I think we can do it with the same formula. Volume is equal to the area of the base times the height. Before we left volume blank because we didn't know what volume was. But this time we do know what volume is. Volume is 48. Now, what is the base of this prism? A what?
3.
What is the base of this prism? Which shape is the base? A rectangle. So the first thing I do is I write down, I get rid of the capital B, and I'm going to write down whatever the formula is to find the base. So length times width. Alright, we're trying to find the height. So we got 48 is equal to, let's see what the length and the width of this thing is. Looks like 8 and 3. So 8 times 3
24.
times the height, which we don't know. So Jalea said 8 times 3 is 24. H, right?
Yeah.
So now all we have is an algebraic expression, right? Or algebraic equation. How do we get H by itself?
Divided by 20.
24H minus.
So
Divided by 24.
you just said 24H minus?
Nothing what I said.
If we got 24 times H, how do you get rid of times 24?
Divided.
By dividing by 24. So 24H divided by 24 is going to be 1H. 48 divided by 24 is 2.
So H is 2.
So the height on this prism
Wow.
is a 2.
That
2.
was so hard.
A 2 goes on the height right there. Alright? So if it's easy, do problem 8.
Okay. Do what?
Do problem number 8. Alright, so here we have our last problem of this lesson. Quiet. So they give us the volume. So just like problem 7, we're going to go ahead, or all the problems use this formula. But like problem 7, we're going to go ahead and plug in what they give us. They say it's 442 for the volume. And then we need to find this the area of this base. So if you take a look at this hexagon, no, pentagon. Pentagon, you're going to have a triangle right here. All of the sides are 4. We're going to have 5 different triangles right here. So it's going to be 5 triangles. To find a triangle, the area of the triangle, you do base times height divided by 2. And then the height of this prism is what we're looking for. So I'll put an H for my height. And if we start working it out, 5 triangles, we need to find one triangle. It's got a base of 4 and a height of 3.4. We're going to divide that by 2, and we still need to find the height. So on my calculator here, I'm going to find the area of one of those triangles. So 4 times 3.4 divided by 2, that's going to be 6.8. Multiply that times 5 is going to give me 34 times H. Divide both sides by 34. And that's going to give me that H is equal to 442 divided by 34, which is 13. So the height of this thing is 13. Now, before you pick your books up, go ahead and turn to page, whatever the practice you're going, 485. And I want you to circle the following problems. 2, 3, 4, 5, and 6. So basically 1 through 6, but I don't want you to do number 1 unless you really feel like doing number 1. 2 through 6. 2 through 6. Yes, I'm checking it.
It's gonna be extra points if we do it.
I don't know all that, but I'm checking it. 2 through 6.